Hey, last time. So, work and power concepts, okay? You're going to be asked some questions regarding work and power. You're going to be given this graph. Yeah, graph, okay? So, work done on crates. 3 different crates, A, B, and C, are each pushed with different forces for a distance of 10 meters, okay? So, crate A was pushed with 10 meters, was pushed 10 meters. We don't know the force it was pushed with, but it generated, let me just make sure we aren't asking you to read the graph. No, okay. So it was pushed with, crate A, 225 Newton, or not newtons, 225 joules, okay? Okay, right up here. Crate B, the the work used to push crate B 10 meters was 150 joules. And the work done to push, or when pushing crate C, was 50 joules of work. Okay. We're going to ask some questions. Down here, like first question, I want to show you the answer. Okay, didn't show you the answer. Whew, that was close. Accordingly, which crate was pushed with the least amount of force? Okay, so down here, we give you all 3 crates. Crate A was pushed with the least amount of force. Crate B was pushed with the least amount of force. Crate C was pushed with the least amount of force. What you need to know is, how does work and distance relate to force? Okay, so we want you to recall up here, work equals force times distance. So if you look over here at this, I copied some things over. So you have the graph. You know that they were pushed 10 meters. You know that work equals force times distance. So which crate, A, B, or C, was pushed with the least amount of force? You have to figure that out. Okay, next question. Question 16. If crate B was pushed a distance of 10 meters, just like before, then how much force was applied to perform the 150 joules of work? Recall, work equals force times distance, so force equals work divided by distance. Okay, so if we want to calculate the force applied to crate B, it was pushed 10 meters, and the joules are 150. What would the force be? Use this equation. Yes. Okay, cool. So you have some options down here. Number 17. If the 225 joules of work done on crate A was done in a time of 5 seconds, then what power was used? Recall, power equals work divided by time. So I'm just going to put it over here. Okay, so power equals work divided by time. So we give you the work in the graph. Okay, you read the graph. Work is over here. Okay, so you like look at the object and go over. Are we talking about crate C? Which crate are we talking about? Crates. Should think of something more interesting than crates. No, it's crate A. Okay, so crate A, not crate C. Crate A. Okay. Remember I told you that's 225 joules of work. I think that's fine to tell you what the graph says. Because reading graphs was kind of like unit 1. Quarter 1. Okay, so 225 joules of work. And we give you the distance. You need to calculate the force. You can do this, okay? Or no, not calculate the force. Calculate the power. So power is work divided by time. Hopefully I didn't just mess you up there. I think it's fine. And that's the last question. Okay. You can do this. See ya.